My fabulous chemistry faithful, video 11. Now we're going to get into bond polarity. There's two videos that go back to back. They're both on polarity, but the first one's going to look at the bond polarity, and then the next one, video 12, we're going to look at the entire molecule's polarity, and they're different things. I need you to not get them confused. Electronegativity differences is how we tell bond polarity. Well, what on earth is it? This polarity is to have a positive end here and then a negative end here. So it has a charge like a battery or a magnet. If I can do that, I can do that within a bond, or I can do that as a collection of all the bonds in a molecule, but that's the difference. Okay, so think of a north and south pole. There's a positive end and a negative end. So what we do is we find what's called the electronegativity difference, the END, and it's an absolute value between the difference of the two electronegativity values. So we've looked them up. In the past, we've studied the electronegativity of this element, the electronegativity of that element. Well, remember, electronegativity is how thirsty an atom is for an electron. Well, if I'm sharing electrons, but I'm crazy more thirsty than you, like fluorine, I might not share evenly, and that's going to produce that polar bond. And if I share evenly, then we're nonpolar, and that's the deal. So when I subtract the two electronegativity values of the two elements, let's say H and Cl, well, we look it up. H is this, Cl is this. Find the two numbers, we subtract absolute value, so it's positive. Take that positive value, and then if it's 1.7, then it's ionic. And remember, non-metal versus or metal non-metal still trumps. Okay, so regardless, if you get a metal and a non-metal, and it is still ionic no matter what the electronegativity is, but we have some different ones. So then there's uneven sharing. Polar covalent bonds is the next step down. This is going to be an END value between 0.4 and 1.7. So if I find something there, they're going to generally be two nonmetals. They're going to be sharing, just not equally. And in the POGL, you're going to see that's like a polar bear and a penguin trying to share an ice cream cone. They might be sharing, but who's getting more ice cream? Let's be honest. Okay. Non-polar covalent bonds form when electronegativity differences are less than 0.4. I have a professor that says it's got to be diatomic. I'm not going to lie, because then it's perfectly even sharing. But this is anything under 0.4, we'll call it even sharing, and non-polar covalent, which means there's no positive, positive and negative and perfectly equal sharing. This is very true for all the diatomics. They have exactly the same END, so when you subtract them, 3.4 minus 3.4 is 0, perfect sharing, everybody's happy, and that is a non-polar covalent bond. So when I do this, I just look these guys up. So HCl is the first one. So when I look up its electronegativity, it's 2.2. Look up HCl, it is 3.2. Subtract them, I get a difference of 1, and that falls in that range of polar covalent from our notes. Okay. Next one, just carbon one time, and I only have to do one hydrogen for this. I don't have to do all four. So I want to make sure we had one of these in here. Look up hydrogen is 2.2. The difference now is 0.4. This bond between one carbon and one hydrogen is now non-polar covalent. But that's just one bond, guys. We're not talking about the entire molecule, just trying to make sure that's clear. Looking up lithium, I got 1.0. Looking up bromine, I got 3. When I subtract those, that's 2, higher than 1.7. So now it is ionic. And now we understand how to calculate ENDs and use them, put them in there, and then now we do the POGL, and we got this whole polarity thing down. And with that, we are donezo. Lots of practice. Keep up the good work, guys.